Alright guys, for today's essential question, we're going to be looking at what is the discriminant and what does its value mean. So the key word for today is the idea of what a discriminant is. So let's just jump right into it. The discriminant is not really anything new. The value of the discriminant is the value up underneath the radical of your quadratic formula. So if you remember the quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a, the b squared minus 4ac, so the value up underneath the square root, not including the square root, that is the discriminant. The value of the discriminant determines the nature of the roots or solutions of the quadratic equation. So for example, if you get a value that is positive for the discriminant, then that means that you are going to have two real solutions. What does that look like on the graph? That means the graph is going to hit the x-axis twice. So in other words, if my discriminant is positive, that means that my graph is going to hit the x-axis in two very distinct places, and that means I have two real solutions. Well, what about if your discriminant is negative? Then that means your two answers are not real. In other words, imaginary or complex. What that means graphically is your quadratic function never crosses the x-axis. And then finally, if your value of the discriminant is 0, that means you only have one distinct solution, which means that your quadratic function only hits the x-axis at one point. So that is what the discriminant means. So it's nothing new, it's just we're giving a vocabulary word to a definition that we have. So let's look at an example. It says, solve the quadratic equation, find the value of the discriminant, and talk about its significance. Well, the first thing that I notice is that this is not equal to 0. So I'm going to add 11 to both sides, and that will give me 2x squared plus 4x plus 3 is equal to 0. So now I know that A is 2, B is 4, and C is 3. So I'm just going to plug it into the quadratic formula. So I'd have negative 4 plus or minus square root of 4 squared minus 4ac all over 2 times 2. Plugging just what's inside the radical in my calculator, that will give me a value of negative 8. Now that's what I want to notice is the discriminant is the value up underneath the radical. Well, our discriminant is negative 8. So what does that tell us about the graph? This means that our two solutions are complex or non-real solutions. So our answers are going to be complex or non-real or imaginary roots and solutions and zeros. And that's what it shows right here. Now, to simplify this to finish solving, I know I'm going to take out an I, and then 8 is 4 times 2, the square root of 4 is 2. So I get negative 4 plus or minus 2I root 2 over 4, and then I can simplify that by dividing all of these trio of numbers by 2, and get negative 2 plus or minus 1I root 2 over 2, and that would be my two complex solutions. All right, let's look at another one. Again, for this quadratic equation, it's not set equal to 0, so I'm going to add 20 to both sides, and that'll give me 2x squared minus 3x minus 20 is equal to 0. So A is 2, B is negative 3, and C is negative 20. Using the quadratic formula, I'm going to have 3 plus or minus the square root of negative 3 squared minus 4 times 2 times negative 20 all over 2 times 2. Plugging just what's inside the radical in my calculator will give me 169, and so that is the value of my discriminant, which means since it's a positive value, I'm going to have two real solutions, and graphically speaking, my graph is going to hit the x-axis in two distinct places. All right, the square root of 169 is 13, so I'm going to have 3 plus or minus the square root of 13 over 4. Breaking this up into two separate ones, I'm going to have 3 plus 13, which is 16 over 4, which is 4. The other one would be 3 minus 13 over 4, which would be negative 10 over 4, which reduces to negative 5 over 2. So my two answers would be 4 and negative 5 over 2, which would also be where, on the x-axis, my graph crosses the x-axis. All right, let's look at one more. 4x squared equals to 28. So again, this is not set equal to 0, so I'm going to move the positive 28 over, and that gives me negative 28. A is 4. I don't have a value for B, so that's 0, and the value for C is negative 28. Using the quadratic formula, I'm going to have 0 plus or minus 0 squared minus 4 times negative 28 all over 2 times 4. I don't need that 0 plus or minus, so I'm just going to put plus or minus, and if I plug what's underneath the radical in my calculator, it gives me 448. Well, that means my discriminant is 448, and since it's a positive answer, that means I'm going to have two real solutions, or roots, or zeros. Simplifying 448, I'm going to break this down. 448 is the same thing as 64 times 7, and the square root of 64 is 8. So that gives me plus or minus 8 root 7 over 8. The 8's cross out, and that leaves me with just the simple answer, plus or minus the square root of 7. And that will be my final answer. All right, guys, that's it for today.